Okay, I think we can get started. My name's Andrew, and I'm a developer advocate at MongoDB. And my focus is on helping developers in our strategic accounts be more successful with MongoDB. I am meant to point out that at the end there's a QR code that you can scan and give feedback. But to be honest, I think we've got more immediate feedback, because as soon as the headphones start turning purple, I can tell people have deserted me and switched sessions over to the other side. Okay, so I'm going to talk about what's new in Atlas Search in MongoDB 7. So the first question I've got for you is, how many people went to the session on vector search earlier today? Okay, probably more than half. That's good, because the first disclaimer is I don't cover vector search in here. I'm going to include the rest that came in search this year. Next question, how many people have either used Atlas Search or at least taken a look at it? Okay, so probably about a third of the people. So just to warn those people, the first couple of minutes or so, you're probably going to be quite bored, because I'm going to do a bit of a level set and explain in general terms what Atlas Search is. I'm then going to get on to the new features that were announced back in June. The first one is search nodes, where we change where you actually run the Atlas search process. I'll have to read this. Managing search indexes across the developer experience. So what that means is there's now new places where you can actually go to and manage your search indexes. Finally, there's search query analytics. So taking a look at what people are searching for and what results they're getting from that, so you can improve your search indexes and your queries. So let's start with a quick Atlas level set. What is search anyway? So Atlas Search is full text search. And we've built Atlas Search on top of the Apache Lucene search engine project. So this is the same search engine that most search products use. So if you've used Elasticsearch, if you've used Apache Solr, if you've searched the Apple website, if you've searched Slack or Facebook, Lucene is the search engine that's doing the hard work. Full text search, how does that differ from querying a database? Normally with an operational database, when you query it, you've got very precise filters. So you're saying, I want to find all records for this subscriber ID where the flag is set to active and it was created in the last 2 weeks. So it's a very precise question, and it's got right and wrong answers. Full text search is a little different. You may not know exactly what it is you're trying to find. You may not type things properly. So it's, I guess the analogy everyone uses, it's a bit like Google. You go to Google with an idea of what you're looking for, and then Google will give you search results based on that. But you may have to scroll a bit to find the ones that actually match what you wanted. Finally, there are other search products out there, and it's not unusual for people to take an operational database like MongoDB and then implement an ETL process to copy some of the data into a search engine. The difference is that Atlas Search is the only one that's been built for MongoDB. And I'll explain some of the reasons why it makes it easier than if you use something, say, like Elasticsearch. So let's get into the features of full text search. The first one is fuzzy match. So full text search is very often used where a website may have a little search bar and people come and type something in there. But because we're humans, we're fallible and we'll sometimes make spelling mistakes. And so fuzzy search gets around that. So even if we don't type something exactly right, you should still get some relevant results from your query. Synonyms. So this is where you want to explicitly say, I know something about my users, and an example here would be if you had a shoe store. You could create a synonym to say that if someone types shoe, then also match it against sneaker or trainer or sandals or Wellington boots. So someone could type one thing, it can still match similar items but with a different name. And this is great, for example, if you think you may have some, say, North American customers and some European customers, because suddenly sidewalk becomes pavement, trunk, boot, etc. And so you can set those up in the database. Custom scoring. So a big part of search is that as well as giving you the matching documents, it gives relevancy. So by default, you'll get the most relevant documents first. So the closest matches to what the search engine thinks you are looking for. But as the developer, you can manipulate that. So for example, if you've got a special offer on for a particular product, then you can change the scoring. So those products, you can tag them so they'll actually appear higher in the ratings. And so when people search for their sneakers, then they get the products that you're trying to push at the top of the list. Autocomplete, this is the cool feature we've all used, that you may go to the search bar and start typing mongodb.l, and suddenly it suggests, do you mean .local London? And then you just hit space and you get it. That's implemented in the search engine. Faceting, this is the simplest one we've all seen is you go to Amazon, you search for a TV, and it starts to come up with results, but by the side, it also gives you different filters you could apply. So it'll have different size screens. So you could see that there's 500 TVs that are greater than 500, or greater than 50 inches. You can also see how many are within each price bracket. And then you can click on those and refine your search. Highlighting, this is where say a web page or an app will actually display to you the snippets within the text that it was searching. And it will tag each to say whether this matched the query or it didn't. So that's why in your rendered page, you can then go and say do bold text for all of the text snippets in the description that actually matched your query. So MongoDB and Atlas Search. So another question, has anyone ever been responsible for writing the software to synchronize data from your operational database to your search database? So something like Elasticsearch. Cool. And keep your hands up if you enjoyed the experience. Oh, one maybe. So we've got someone with strange tastes at the front. But so I speak to a lot of developers, and that writing that software probably ranks at about the same level as using object relational mappings. It's a piece of software that people don't like writing. It's complicated. It's problematic. So with MongoDB, it does it for you. And with MongoDB, all you have to do is say, for this particular collection, these are the fields that I want to be included in my search index. Then MongoDB Atlas is going to be responsible for setting up and maintaining your Lucene search indexes. So as something changes in your MongoDB operational data, the search index will automatically get updated in close to real time. And so everything about MongoDB and the developer data platform is trying to make it simpler for developers so you don't have to write that glueware just to add new features to your database. So finally, what's new in Atlas Search? We're going to start with search nodes. So let's start off with looking at the classic way that MongoDB adds search capabilities to Atlas. In the diagram, we can see a regular replica set that's got a primary and two secondaries. On each of those nodes, it runs your standard MongoDB process for your regular MongoDB queries, but also a process we call MongoT. And it's the MongoT that has the search indexes and is running Lucene. So both of those processes are actually running on the same nodes within your cluster, which makes it super easy to set up because you don't have to configure any extra hardware in your cluster. You just say, I want to add some search indexes. However, it can cause some problems. One of them is trying to decide how big your cluster should be. So what instance size should you need? Do you need sharding? How many shards? So it's more complicated because you've got to take into account both the MongoDB workload, but also the search workload. There can be resource contention. If your users happen to be running a lot of particularly gnarly full-text searches, that could potentially squeeze out resources from your MongoDB query. So maybe perhaps stopping someone checking out a shopping cart, and that's not great. There are potential issues that if the MongoT process runs into problems, then that can also bring down the MongoDB process. Obviously not good. And maybe the biggest is it makes it very hard or impossible to independently scale your search workload from your regular MongoDB workload. So if, for example, users start doing a lot more search, then you have to increase the size of your instance sizes, even though the MongoDB workload may be exactly the same. So you may be adding more resources than you actually need. So with search nodes, we move from that tightly coupled architecture to having your regular replica set, and on each of those nodes, it just runs the MongoD just as it always has done. And then we have an extra set of secondaries, where these secondaries are only there for running your Lucene or your MongoT process. So the benefits to this is workload isolation. So your search workload goes up. It's not going to impact people who are trying to check out with their shopping cart. Better performance at scale. So quite often people have had to go from a single replica set to a sharded cluster just because the extra workload that search is putting onto the nodes. So by separating them out, you can very often avoid having to go to a sharded architecture. Higher availability. So if something goes wrong with your search nodes, it doesn't affect your regular Atlas database nodes. And this is more for people that have used Atlas search quite a bit. If you're working at high scale, then you get faster index builds because you've got extra resources on those dedicated nodes. At the moment, search nodes are in private, what are we calling it? Private early access. And so if you want to make use of it, you can scan this QR code or go to mongodb.com/DASAL. Or if you've got an account prime you've got an account team that's already assigned to your company, you can speak to them and they can hook you up. And then complete that form and you will get the opportunity to join the program, try out the search nodes, and most importantly, give us feedback. Because the reason we have these early access programs is so we can learn from your experiences. So let us look at how you set this up. So I'll let this play through once, and then I'll describe what's going on. So what you're looking at here is the Atlas UI, where you configure a new cluster. Let it play through. Okay, so what's changed is now when you create a new cluster and you go to the workloads isolation section, you have the option to say that you want to add search nodes. And you can have anywhere from 2 to 32 search nodes. And what's really important is you can choose different instance sizes for your search nodes from your regular MongoDB nodes. So you just choose what size search nodes you want, name the cluster, hit create, and you get your cluster up and running as normal. A current limitation, at the moment, search nodes are only available for single region replica sets, so no sharding in AWS clusters. Obviously, that is going to change. This is during the preview phase. But one of the advantages of joining the DASL program is you can actually influence this and just put pressure on to say, I need it on Azure, I need it on clusters, on sharded clusters, I need it on Google. Advantages of joining the program, as I said, you can influence where the product's going. And this same product is not just for the search nodes. As we release new content into the preview mode, you'll get access to those features as well. We have dedicated MongoDB community forums, so you can exchange messages with other people that are working with the new features too. And the final one is If you're looking for a little bit of promotion, a little bit of publicity, we love sharing customer stories about how they've used this technology during the preview process. Quick question, can I still use the traditional approach where I co-locate MongoDs and MongoTs? Guesses? We probably wouldn't have this slide if the answer wasn't yes. So yes, you can. And both architectures are supported both for development and for production. Or at least it will be once it's out of preview. So now we've allocated the resources for our cluster. The cluster's up and running. We've got MongoD processes. We've got MongoT processes. The next stage is actually making use of that hardware to actually be able to do searches. And the next phase of that is to create the search indexes. And so this is where we create those search engines in the MongoT process that are going to be used by Lucene. Search index management. At the moment, you've got a choice, or previously, you've had a choice about where you can create your search indexes. The original one was Atlas, the Atlas UI. You can also do it through the Atlas API. And more recently, you've been able to use the Atlas CLI to do it. What we changed this year is we recognize that not everyone wants to create their indexes through those tools. And so we've added 3 new methods. You can now create them from the MongoDB shell, Mongo shell. You can create them through drivers. So if you want to actually have it as part of your application to set up the indexes, you can do that. We don't have it in every driver yet. The first 2 drivers were C# and Node, but the others will be coming along. And then later this year, you'll be able to create them in Compass. So how many people use MongoDB Compass? OK, sort of a bit over half. For those that don't, please try it out. It's a free desktop tool, and it's a really cool tool for manipulating your indexes, looking at visual explain plans for your queries, etc. So it's a free tool. It's really useful. And later this year, you'll also be able to create your search indexes through Compass. If we look at the Mongo shell, so the Mongo shell gets 4 new commands. They're kind of what you'd expect to have. The first one is to create a new search index. And in there, you give it the name of the search index and then the configuration. So in this case, I've called my search index. And then for my configuration, I'm just saying for my mappings, I want it to be dynamic. So what that means is that every single attribute in documents in this collection are going to be included in the search index. So that's the simplest way of getting going, and you very quickly get results. But then you realize that there's actually a lot of fields in there that it doesn't make sense to do a text search on. So I can now come back and use the update search index command, where I say my search index is the name of the index I want to change. And now for my mappings, I'm going to set dynamic to false, and then explicitly list all the fields that I want to be included in the search index. In this case, it's just one, which is the field called description. At some point in time, you retire a feature or you come up with a new search index which makes this one obsolete. You can remove it by doing drop search index. And if you want to see what search indexes you have on your collection, then you can use get search indexes. And then that will also give you some status information. Drivers, I'm not going to show you the syntax for drivers, and that's because the syntax varies with a particular language. Because just like all the other features in our drivers, the API is designed to be very familiar with people that work in that programming language. So the Java API is going to be different from the C# API just because developers are used to seeing different approaches. And then, as I say, MongoDB coming later this year, and that's a GUI, so there's no commands to show. So we've got our search indexes. We've written some aggregation pipelines that actually use those indexes to do full text search. Now we actually want to see what people are doing with search. And the reason we do that is we want to understand how people are using our service. What are they searching for? Are they searching for things that I don't actually have in my catalog that I could add? Are they searching for a particular thing where maybe I can do, if lots of people are searching for that, I can do some promotions on it? So this is where search query analytics come in. So, the questions we get answered for, what are people using search to find most frequently? And here we've got a graph, and we can see that for the MongoDB documentations, the most common search is find, and there's been about 156 searches for that, which makes up a little over 1% of all of the searches. Just as importantly, what have people been searching for where it didn't find any relevant results? And so here we can see that there's been 1,700 queries that didn't get a match. Okay, so get ready. We're now going to do another sped up demo of how you actually use the search query analytics. Okay, so with our search index, when I go to our queries, I now get given some sample code. So this is the code that you actually have to add to your client-side queries. And so we can see in here that there's some extra code I need to put in. And this is going through the same thing again. So I just go to the query analytics, get these code samples, and I can see that I need to add a parameter called tracking. And the tracking is a document that contains a field called search terms. Now, I go to the search tester, and I've got my search query in there, and I can now add that code in. So I'm adding a tracking section saying my search term is waterfront, which matches what I was actually searching for. Then I hit search a few times. Then I come back, and let's change my query to be school. So this is an Airbnb type data set. And again, let's click that a couple of times. And now, when I go back to my query analytics, I can see these are the search terms. Waterfront has been searched 8 times. I can click down on that and actually see the query that was executed. So the instrumentation is client-side, and then through the UI, you can actually see the results. Then there's also the opportunity to see what are the searches that didn't find any relevant results. And at the moment, that is, we've gone past it, but there were 0 misses. So 0 queries where there were no matching results. So let's go back to my code, and I change my query to ASDF. Hit search a few times. Now when I go back to my analytics and scroll down, I can see that there's been 4 queries with no results, and I can see that it was ASDF was the string that I was searching for. And again, see the percentage, see the actual queries that people were running. Okay, so how would you use this data? First one is looking at the most common queries. So in my online shoe store, I see that people are doing lots of searches for basketball shoes. And we stock lots of different brands of basketball shoes, but we also know that LeBrons are particularly popular at the moment. And if people look at the product page for LeBrons, they're much more likely to click the button and actually follow through and purchase them. So I could decide, because I've got so many people searching for basketball shoes, let me just twist the score so that the LeBrons come up as the more relevant results. So people see those first, and they're more likely to click on it and then click through and buy them. I can see that the top search term that I didn't find any matches for were Air Jordan. And the reason for that is I'm out of stock of Air Jordans. But I do know that I've got lots of other Nike shoes there. So what I can do is I can go and add a synonym to say that if someone types Air Jordan, also match that with strings that contain Nike. And so that way I can start selling them some Nike shoes even if I don't have the Air Jordans that they wanted. So Just to summarize, we did a quick level set of what Atlas Search is. Search nodes, so that's the ability to have your search processes running on separate hardware from your MongoDB process. So that gives you things like the workload isolation, extra scalability, etc. And then we looked at the search index management, which is fairly basic. This is just, you can go to different places now to actually configure your search indexes. Then finally, we looked at the search query analytics, where you can see what are the most common queries, but also what are the queries that people are running that we don't have a match. And then you use that data to refine your search indexes, refine your queries, possibly even redefine what you actually stock. So if you see that lots of people are searching for Air Jordans, but there's no matches, that's a good hint that maybe we should start stocking Air Jordans. And the other thing that's new is vector search, which has been covered elsewhere, so I'm not going to cover that. And then the other small thing is we've added sort in the $search aggregation stage. So previously and by default, when you do a search, the results you get back are sorted by the relevancy, so the most relevant results first. You can now override that, and when you do your $search in MongoDB aggregation, you can now specify that you want to sort on a different field. Okay, so in terms of questions, because we're all in this strange world, what we'll do is I'll be around after the talk, so if you've got questions, come up and pester me. And I think the happy hour should be starting any time now. And then finally, I see everyone's stuck with me, so if you do want to give some feedback, it would be appreciated, and that's the QR code. So thanks, everyone.